All right. Hello. Welcome everyone to the weekly webinar where QuickSight customers will learn about product functionality, new feature launches, best practices, and tips on how to improve user experience and gain technical knowledge from QuickSight solutions architects and product managers. In today's session, we'll learn about how to improve filter performance for direct query dashboards. My name is Karthik Thamarajan, and I'm a senior QuickSight solutions architect. Before we get started with the discussion or today's webinar, I would like to briefly touch upon our QuickSight community. It's a one-stop shop for all of your BI journey. Basically, QuickSight community is a place to connect with other QuickSight users, and it is the first place you should look for answers to your questions. You can search for answers, ask new questions if you need, connect with other users, and find new resources as well. We also post all the latest announcements, blogs, and learning resources here, including many examples created by me and my colleagues under our Demo Central section as well. Well, if you have not already signed up, I highly encourage you to sign up to our QuickSight community. You can use the QR code that you see on the screen to sign up, and you would get access to our searchable Q&A section. Like I mentioned earlier, you can stay updated on our weekly online learning series. I would like to call upon a quick change here, especially for the Americas region. We have been conducting our weekly online learning series every Wednesdays at 10 a.m. Pacific. However, going forward, it will be hosted every Tuesdays, 10 a.m. Pacific. No change for the the Central European region, and the time zone is still the same. All right, with that said, any question that would be part of today's webinar will be taken via our QuickSight community. Like I said, if you have not already signed up, feel free to go ahead and register into our community and you can start asking questions. And when you ask any question related to today's webinar, ensure that you tag the question with the hashtag that you see on the screen, which is QLS dash filter dash performance. Let me quickly show you how to create a question and also tag it, and then we'll jump back to our presentation here. All right, so this is the landing page of our QuickSight community portal. On the bottom, you would see a couple of tiles. Once you register, click on the Q&A section at the bottom, and you will be taken into this screen where you can actually see all the questions posted by other users in the community. You can browse through this question. We have a search box on top, so you can search for any existing questions which might have a response. Or if you want to create a brand new question or any question that is part of today's webinar, so go ahead and click on the blue button which says new question. So you should see a text box to type in the title. And then ensure that it is under the Q&A section for the drop down, and for the tag, use the tag that I just shared on the screen earlier, QLS dash filter dash performance. So ensure you tag it appropriately and someone from the team will answer your question. And then don't forget to give a description of the question and then submit your question. I'm not going to submit this question. I'm just going to click on close. And let's jump back into our presentation here. Finally, before we jump into the discussion, I wanted to let you all know that today's session is recorded as well. And towards end of the week, you will get access to this video. You can access them either from community or from the YouTube channel, which is the Amazon QuickSight YouTube channel. All right. So for today's discussion, let's start off with the high-level overview of the use case or what problem you're trying to solve here. And then we will take a high-level look at the solution that we propose. We'll follow that with a quick demo demonstrating how the solution can be implemented, and then we can wrap up the discussion. So for today's discussion, we will try to understand or try to figure out how to tackle or improve the performance of filters for dashboards that is designed or authored using direct query datasets. But the natural question is why would our customers tend to use direct query data sets for building their dashboards, right? So at a high level, there are two scenarios where you would see this fit. One is if your dashboard demands near real-time data requirements, then you will resort to using direct query data sets to build your dashboards. Or if you happen to have compliance requirements which restricts moving data into our spice storage capacity, which is our in-memory data engine, then probably you would have no choice but to use the direct query dataset option that we offer. Also, the third category would be, we know today's Spice supports up to 1 billion rows per data set. And if your data requirements happen to exceed 1 billion rows, then probably it'll be better off using the direct query data set as well. So these are the scenarios where, as an author, you would end up building a dashboard that is using direct query data sets. However, the downside with this design is, the performance itself, right? You might have performance issues with your visual loading. You might also see performance issues with your filters, wherein when your user clicks on the filter, it might take few seconds to refresh that list of values for dimensions. Like if you have a customer dimension or if you have a product dimension that you're showing as a filter. Now let's actually figure out how we can tackle this scenario. Like you would approach a dashboard, we are going to take a similar approach for filters as well, right? Filters are no different from dashboards. In fact, that's one of the interaction touch points for your end users when they land onto your dashboard, right? So we want to ensure they have a good user experience when they click on those drop downs and those values, show up instantly or immediately. So for visual performance, we try to aggregate the data. We try to break down the data set into smaller components. So that way, the visual loading time is a lot faster, right? So similar approach can be taken for filters as well. So we recommend creating dedicated data sets for filters, right? So now you're bringing down the whole volume that needs to be scanned by QuickSight in this direct query mode, right? If you're looking at creating a fact which has millions or billions of rows and connecting that to dimensions. Now, just to bring back those unique list of values for your filters, it's going to scan through large volumes of data. However, if we break that down and create dedicated data sets just for filters, now you're just handling a subset of data which is a lot smaller than your actual data set itself, and in turn, which will improve the performance of the filter itself to bring back those unique values in those drop downs. Now, once you create those dedicated data sets, the next step will be how can I link that to my actual data sets that I'm using for showing my visuals or my charts on the dashboard, right? So there are ways that we can achieve it. One way is to use parameters. We'll again take a look at that in our demo. Now, once you have linked it with the parameters, if you want to further improve the performance for your filters, you can certainly resort to using Spice. You can create dedicated data sets for filters and also put them in Spice, so that way you can get higher performance. However, going back to our earlier discussion, if you have compliance requirements, then probably you will end up still using a direct query. But like I mentioned, you will be working off of a smaller subset of data rather than scanning the entire table itself. And finally, the most recently launched feature within QuickSight, which is the dataset parameter feature, can also be used along with the parameters that we create for our filters to improve the overall performance of the dashboard, not just the filters, but also the overall performance of the dashboard itself. We'll also talk about that during our demo. So with that said, let's quickly switch screens here. I'm going to exit the presentation and jump back into the QuickSight screen here. All right. So this is landing page of the QuickSight console. Let me get into the dataset screen. And for today's demo, we will be tackling 3 datasets. The one is the sales event demo. Let me get into this dataset. So like I mentioned, this is a direct query dataset. Let's take a look at the data model. So all of the tables that you see here is currently being sourced from my Redshift cluster under the hood. Sales table happens to be the driving table, and then I have sales connecting into events table. And then there are extension tables that I'm connecting to events, which is the category and the venue itself. So you get the idea. So this is a model, a data model that I have created. We don't have, like to simulate this performance issue, I don't have huge volumes of data. I think we have close to 25,000 records in this table. But I just want to emphasize on the approach rather than actually showing how the performance improvement can be done itself, right? So that's the idea here. So now that we understand this data model, let's jump into our analysis or the authoring mode. All right, so the first tab that you see here is connected to that same data set, the sales event demo data set, which is in the direct query mode. And all of these visuals are currently being sourced from the data set. So it is going to fire a query, it is going to make those joins, combine the sales table with events table, and then extend that to bring back the category and venue details as well, right? So all of that is happening behind the scenes. Now, if I create a filter off of that data set, so this event filter that I create, now just to bring back this data, this unique list of events, it is again going to resolve those joins and then scan through the table or all those records and then bring back this unique list, which is an expensive operation. And here you are just talking about 20,000 rows. Now you can imagine if this runs into millions and billions of rows, this is certainly going to take a few seconds to show up this list here, right? So what we would do rather is, let's switch into the second tab here. Now, all of the visuals are still coming from the same data set, the sales event demo data set. But I have this small visual here, which is giving the unique count of events, which is coming from a different data set, which is created dedicatedly for the filters itself. Now let's jump back to this other tab and take a look at the events filter data set. So I've loaded this data into Spice, the same tables, but here I have excluded my fact. I'm only focusing on my dimensions, so I'm trying to bring in all the unique permutation combinations between events and venue as an example. But if you have something else, you could also add that if needed. You can also break this further down, like you can have a dedicated data set just for events, you can have a dedicated data set just for venue, so on and so forth. So depending on the volume of records that you want to handle and what's the level of performance that you want to provide, you can take a decision based off of your use case. But for this demo, I'm just combining event and venue and taking all of the unique combination for this dimension and storing that into Spice. Now let's jump back to the authoring mode here. So like I mentioned, so this visual is powered by the event filter only data set. And the data that you see here on top, the drop down here, is also built off of that data set. So now naturally we are just scanning through a smaller subset because we only have events and venue joined in this data set. And when I go into one of my visual and create a filter, or rather let's take an existing filter, the event itself. The key step to do here is the scope of the filter, right? Now we are going across data sets. Now the event name is coming from a different data set and all of your visuals are coming from your direct query data set, right? But how do I link those two values is the key question here. Now QuickSight has this feature where if you choose all applicable visuals and if the filter that you're using happens to have same name and same data type across both these data sets, QuickSight will automatically link them up. So you don't have to do any custom solution or any further changes are needed. It is going to naturally link them. And that's the feature that I'm using here in this first approach. So just ensure the scope is all applicable visuals. And now if I apply a filter from the secondary data set, which is only for events, you can see all of the visuals are also responding. Right? So here, essentially what we did was we created the event from the secondary data set, and then we use the scope of the filter to ensure it is applicable to all the visuals. So that way QuickSight seamlessly handles that association as long as the name and the data type is same, right? Now you wouldn't have this scenario for all your data sets, right? You wouldn't have the same name. So your secondary data set might have the name as event, and then your fact might have or the direct query dataset might have the name as event name or something of that sort, right? So if there is a mismatch, then that's where you'll have to use parameters. Now going into the third tab here. So all I did here was created a parameter, call it p event name, and this parameter is now linked to a control which is connected to my secondary data set. So let me show you the control option here. So you can see I'm linking this drop-down value. So again, this is a dynamic way to populate this control value here for this parameter. So I'm just linking it to the smaller data set, which is the event filter only data set. So the values in this control will be refreshed and it is dynamic. It is not a static list. So that way you stay current with all the values that are getting updated into this data set. And you're also passing this value into the parameter, the p event name. And when you create a filter, it is as simple as just referencing that parameter. So let me show you how that is done here. So I'm going to click on edit. And you can see I'm just referencing the same parameter here, the p event name, which is connected to a control that is linked to the secondary data set or the data set that I created for the filter. You can add another filter if needed, just to demonstrate. Maybe I can choose venue. Let me add a filter on venue name. I'm going to click on edit. I'm going to choose all applicable visuals. The filter type is going to be custom filter, but I don't have the parameter yet. So let's first go ahead and create the parameter. I'm going to call it p venue name. All right, let's go ahead and create a control. Create a drop down. Let's link it to a data set. I'm going to use the data set that I created for my filters and link it to a column called venue name from that data set. Then I'm just going to click on add. So I have my control created and all of these values are now coming from the secondary or the data set that I created for filter. And now let's get into the visual and ensure we have linked it to the parameters. I'm just going to choose custom filter. And then choose use parameters, and you should see the venue name parameter show up here. When I click on apply, you should see any changes we drive from this control should now show up in all the visuals. Of course, there's no data for this venue. Probably I'll just change the event. So you can see how we are tackling the performance issue with the filter by creating a dedicated data set and then linking up to a parameter, which in turn is hooked to a control that is dynamically picking the list from the secondary data set that we created. Right now the third option is let me reset this filter real quick here. We anyway created the parameters at the analysis level, then we can further extend that to be dynamically passed into the data set itself. So now the improvements that we see for the filters can also be extended to our visuals as well. So what I mean by that is let's go back to the other tab and take a look at the third data set that I created. So this is a sales event custom query data set. This is again working in the direct query mode. Let me do an edit. So here I've just created a simple custom SQL. Essentially, it is the same data model that we saw in our first scenario, where I had the sales table joining into events, and then there was an extension to the events joining into category and venue, right? The only difference is here, QuickSight has enabled this new feature to pass the parameter in a where clause in your custom SQL in the dataset layer. So this opens up multiple opportunities now to enhance performance, right? So dynamically, depending on what the end user is selecting on the UI or in the dashboard, we can now cascade that during runtime into this data set. And now we are reducing the load on the database itself, right? So imagine if you're passing the event name into this data set. Now this whole query is filtered for that specific event name, and it is just going to query for that event. So the performance of your visual also is going to be a lot more faster, right? However, in the earlier approach, we had a fixed data model. So QuickSight was going to fire the SQL related to that data model. After it brings the data over, then the filter was getting applied at the QuickSight layer. So you anyway spend time working through that query, bringing all of the data, and then applying a filter. But in this approach, you are seamlessly, narrowing down the data set by passing the parameter value. So now that we have this ability, let's go back to the dashboard, or rather the analysis, and see how things work there. So I have this event selected. As you all know, parameter that we create can go across sheets. So I have this 3 doors down event that I have selected in this sheet. So now let's go back to the fourth sheet here. So all of these visuals are currently coming in from the custom query. But the difference is any change that I drive from here, from this parameter or control, will also be seamlessly passed into the data set. Now the data set that I query itself is now filtered for the selected value during runtime. So it certainly makes a lot of difference. So by creating parameters, you can certainly enhance not only the performance of your filters, you can now extend that to your data sets if you happen to use a custom SQL. Obviously, that will be in a direct query mode, and you can narrow down the volume of data that you're trying to query from your underlying database. Hope this was useful. Before we wind up, I quickly want to talk about a few upcoming events. Let me go back into my presentation mode here. So for next week, stay tuned for our advanced QuickSight cost and usage analysis webinar. It's going to be, like I said, it'll be run every Tuesdays in the Americas region going forward. So that's going to be June 6th. All right. Thank you so much for your time today. Like I mentioned earlier, if you have any questions related to today's webinar, feel free to post it on our QuickSight community and then tag it accordingly. And then someone from the team will respond to your questions. Once again, thanks for your time. Appreciate everyone joining today's webinar. Thank you.